Hello again, everyone. Dr. Tom McNamara here for our course in college algebra. We are going to continue discussion of polynomial functions. Okay, so if there's a theme to this course, the theme is all about functions. So we've gone over several different types or categories of functions. The simplest type of function that we've discussed is a linear function. If I gave you a linear function, you should automatically be thinking, okay, what's the slope? And what's the y-intercept? Or any point on the graph, but typically we start with the y-intercept. So for a linear function, you're thinking, what's the slope? What's the y-intercept? If I know those two things, I know everything about the function. I can draw the graph quickly and easily. I can compute inputs and outputs. I can do everything I want to do with that function. We've also talked about absolute value functions. Okay? If you see that you're dealing with an absolute value function, you automatically know the shape of the graph. You know it's a V shape. So now the key pieces of information are, how is this thing shifted around? So you're looking at the function and seeing what transformations have been applied. Okay? If you are dealing with a quadratic function, you're automatically thinking, what's the vertex? If I find the vertex and I know whether it opens up or down, I've got essentially everything I need to deal with that function and to answer any questions somebody might throw at me about that function. So, for the polynomial category of functions, we're going to go over the key pieces of information. And one of those key pieces of information is the end behavior of the polynomial. In other words, how does this polynomial end up looking? My truck was over there. Okay, so the end behavior of a polynomial is going to be determined by two factors: the degree and the sign of the lead coefficient. Okay, and both of these are ideas that we discussed in our previous video. So I'm going to make a little table here of a bunch of partial graphs. Okay, so up here in this section, I'm talking about a polynomial with even degree, positive lead coefficient. So it's not so much the specific value of the degree, but which category it fits into. Is it even degree or is it odd degree? So over here we're talking about polynomials of degree 2, 4, 6, etc. Here we're talking about polynomials of degree 1, degree 3, degree 5, and so on. Okay, if you have even degree with a positive lead coefficient, your graph ends up looking like that. Okay, now we've already seen a specific category of even degree polynomials, and those were the quadratic polynomials. Those are degree 2, and we remember those graphs are U-shaped graphs. So in other words, the end behavior is looking like that if the lead coefficient is positive. Remember, if the lead coefficient is negative, then the parabola opens down for a quadratic. Well, same thing with a general even degree polynomial. If your lead coefficient is negative, you're going to end up looking like this. Now, if I had a quadratic, I know exactly how these are connected. If it's higher degree, like degree 4 or degree 6, it can have a couple of wiggles in there. So we'll need a little more information to be able to fill in the rest of this picture. So these are just partial graphs. Okay, so if you have odd degree, like degree 1 or degree 3, you end up looking like this, right? We saw the graph of y equals x cubed in a previous video. Y equals x cubed is looking kind of like that. Not kind of like that, it looks exactly like that. Okay, goes up on this side, down on this side. That's the case for general odd degree functions. As before, I can't really tell you how to fill it in without some more specific information, which we'll talk about in the next video. If you have degree 5, there can be quite a few wiggles in here. If you have degree 3, there can be wiggles. If you have degree 1, there are no wiggles and it's just connected straight. It's a line if it's degree 1. Okay, and finally, if we have odd degree and negative lead coefficient, that's our picture. So, I'm going to need you to commit these 4 partial graphs to memory. Because when we're dealing with a polynomial, and I start asking you questions about it, like draw the graph of this polynomial, etc., this is the first key piece of information. What's the end behavior? So really, that's asking, what's the degree, and what's the sign of the lead coefficient? Because if you know both of these things, now you know how the polynomial ends up looking. Okay? So, end behavior, one of the key facets of a polynomial function.